Okay, right now we're going to go over the problems that were on the topic 1 review. Okay, a reminder that this is not due in class tomorrow. It is going to be due in class Thursday before you take the test. Okay, so just make sure this finds its way to the black bin Thursday when you come in, and you will be getting some bonus points if you do the process and these steps correctly. Okay, you'll be getting some bonus points on the test, and hopefully this will better prepare you, or at least treat this as a nice study guide for topic 1. Now, in the first two here, we are going over some topics from 1.2 we are going to need to solve. So we have 3 parentheses 2x plus 6 and parentheses is equal to negative 40 plus 4. Okay? So as we've done before, every time we have a set of parentheses, we are going to have to distribute. Okay? That's going to give us 3 times 2x, which is 6x. We have 3 times 6, which is 18, is equal to negative 40 over 4. Those are like terms. Let's go ahead and make that the negative 36. Okay? Next, we got to get x by itself. So let's get rid of a plus 18 by subtracting 18 from both sides. The 18s on the left cancel out, leaving us with 6x is equal to negative 36 minus 18. That is negative 54. And then we're going to get rid of a times 6 by dividing both sides by 6. 6's on the left are going to cancel out, leaves us with x is equal to negative 54 divided by 6. When in doubt, calculate it out. So if you use your calculator, or if you know this off the top of your head, we should end up with negative 9 for our x value there. Okay? And remember, as we're going through these problems, I do recommend you trying the problem on your own first. If you get lost a little bit, maybe look through your notes and see if you can find problems very similar to this. And then after you get that done, or at least you have attempted it one time, then watch the video that we're doing here and see if that either you got the problem right or if you have to make some corrections to it, okay? Once again, this is going to be hopefully a better study guide for you to use for your test on Thursday. So once again, we have the same process here, and we'll apologize for some parentheses or if a number line got lost here in the copying process. But we still have a bunch of parentheses here, so we are going to be distributing. We will need to distribute the 5 there, and we are going to have to distribute the 3 over here. Okay? So if we distribute, we have 5 times x, which is 5x, 5 times 1, which is a positive 5. We still have that minus 6. We still have that 2x, and now we need to distribute the 3. So 3 times negative 1 is negative 3. 3 times x is 3x. Okay? So let's see what we end up with here when we combine like terms, because we have some like terms on both sides. Okay, so we have a 5x, then I have 5 minus 6, that's minus 1. And then over here we have 2x and 3x. We add those together, we get 5x, and then we still have the minus 3. Now, at this point, we will notice that we have 2 equations that are almost similar to one another. Okay? Some of us might be able to look at this and realize, hey, the 5x's are the same, but the rest of it's not, which means it's going to give us a no solution. And if we can't see that, reminder, if we just do one more step, if I try to combine my variables together by subtracting 5x from both sides, the 5x's are going to go away, and we're going to be left with negative 1 is equal to negative 3, which is a false statement. Negative 1 is not equal to negative 3. So this one for here would have no solution. There is no number I can plug in for x that works to make this a true statement. Okay? Now the next 2 here are dealing with consecutive integers. So if you want to try on your own, you can pause the video. Okay? Now, we're looking for 3 consecutive integers whose sum is 288. Now in this one, we don't see anywhere in here where it says odd or even. Now remember, odd or even lets us know that we need to add 2 each time. This one, since it doesn't have odd or even, we know we're going to have to use plus 1. So the first term we don't know is x. And then for every term after that, we have to add 1 to what we had before. Okay? So since we're looking for 3 terms, there's our first term, x. Our next term would be x plus 1. Our next term after that would be x plus 2. So there's our 3 terms. Now, if we add all 3 of those together, set it equal to 288, we should be able to find the 3 integers they're talking about. So let's go ahead and combine like terms. I have 3 locations of an x. I have x, x, and x. That's going to give us 3 x's. Okay? So there, and there. All right? Then our regular numbers, we have 1 and 2. We add those together, it's going to give us a 3 is equal to 288. Then we go about our process here. So we're going to get rid of, we have 3x plus 3 is equal to 288. Get rid of plus 3 by subtracting 3 from both sides. Okay? Then, 3's cancel out on the left, leaving us with 3x is equal to 285. Then we are going to get rid of a times 3 by dividing both sides by 3. I'm running low on room, so I'm going to write it over there. 3's cancel out on the left, giving us just an x is equal to 285 divided by 3 is 95. Okay? Now keep in mind, that's not our final answer. That's just the first term x. We still have to find x plus 1 and x plus 2. Okay? But simply all we have to do is go back to the original number and plug it in. So 95, we add 1 to it. It's going to give us 96. 95, we add 2 to that. It's going to give us 97. Those are the 3 consecutive integers that we were looking for there. Okay? All right, on this one, a little bit easier, I think, because there's only 2 consecutive integers whose sum is 85. Now, once again, we do not have the word odd or even there, so this is going to be another plus 1 problem. Now, they're only looking for 2 consecutive integers, so with the first one being x, the next one's going to be x plus 1, and there's our 2 consecutive integers. So if we simply add those 2 together and set them equal to 85, we should be able to find the 2 integers. So we have x and x, it's going to give us 2x there. And then we have just a 1, so we're still going to just have plus 1 there, is equal to 85. Doing the math here, get rid of plus 1 by minusing 1 from both sides. It's going to leave us with 2x is equal to 84. Okay? And then we're going to divide both sides by 2. Write our answer over here. 2's on the left cancel out, leaving us with x is equal to 42. And once again, that's not our final answer. That's just one of our answers. Oops, sorry about that. Let me try that again. Dividing both sides by 2, and it makes it x is equal to 42. And once again, that's our first answer, but we also want to find x plus 1, which would have been 43. So our 2 answers there would have been 42 and 43. And a reminder, we can always check these problems with the consecutive integers because are these 3 consecutive numbers? Or if we had a problem that had 3 odd or 3 even, do we have 3 odd consecutives or 3 even consecutives? And always make sure these 3 numbers and this one need to add up to 288, and these 2 numbers over here need to add up to 85, in which case they do. Now we have dp is equal to rst. This is definitely one of the ones that gave a lot of people fits because there are no numbers. But if we treat these variables like numbers and treat the only variable they're wanting us to get by itself as the variable, so for instance, if this rs, instead of saying rst, what if it said 16t? We would get rid of 16t, or we'd get rid of the times 16 by dividing by 16. So if we just treated both the r and the s like numbers, right now they're being multiplied by t. To get rid of multiplied by r, we're going to divide by r. To get rid of multiplied by s, we're going to divide by s. And what we do to one side of the equation, we have to do to the other. Now, as we do that, we have r divided by r, which is just 1, so it goes away. S divided by s, it's just 1, so it goes away. And then we take a look, and the only thing that we're left with over there is t. Okay? The only thing we're left with on the right side is t. Now, dp over rs. We don't have any common terms on top and bottom there, so there's nothing left to simplify. So our final answer here would be dp over rs. Okay? Okay. Now, the remaining problems that we have on this review here are dealing with 1.5 and 1.6, which were the inequalities and the compound inequalities. Keep making sure. Some problems need you to graph, some problems don't need you to graph. Okay? Now, it's always great if the problems that you don't need to graph, if you do them for extra practice, but if you're running low on time, just make sure you do what's required of you. So you can go ahead and pause the video and try these problems out if you want. Okay? So we have 3m minus 4 is less than or equal to 17. Okay? So what we'll do here, once again, we got to get rid of the minus 4. We'll get rid of that by adding 4 both sides. 4's cancel out on the left, leaving us with 3m is my bad. It's less than or equal to, my bad, less than or equal to 17 plus 4 is 21. And then finally we get rid of a times 3 by dividing by 3 on both sides. 3's on the left cancel out, leaving us with an m is greater than or equal to 7. Now this problem did not require us to graph, but we simply could graph this on a number line. At the point 7, we would have a closed circle, and since the variable comes first here, this arrow would be pointing in the direction of the inequality, which would be to the left. Okay? Let's try this one over here. Probably should go ahead and try to simplify this distribution here. So we'll have to distribute the 4 throughout the set of parentheses. Okay, we didn't do anything over here on the left side, so it's still 4x plus 4 is greater than or equal to 4 times x is 4x. 4 times 6 is 24. Now we might notice we have something similar to we had a problem up here where we had both a 5x and a 5x on both sides. Now we have a 4x and a 4x. Okay? So once again, when in doubt, let's go ahead and try to combine our terms here. So I would subtract 4x from both sides and combine them together. They cancel out, and let's see if that leaves us with a true statement. I have 4, I have 24, and the inequality is open up towards the 4. So this is saying 4 is greater than or equal to 24, which is a false statement, so this one would be another one that would say no solution. Now the other example we could have had was infinite solutions. If this inequality would have been flipped around the other way, where it would have had the open mouth towards the 24, it would have been a true statement, which would have meant that any number we plug in for x at both locations would make this whole inequality true. But being the fact that this one has 4 greater than or equal to 24, a false statement, there's nothing I can plug in for x at both locations to make this true. Okay? Now these bottom two here, we are going to have to graph on a number line. So it does say solve and graph. Solve means to get it to be variable inequality number and then graph on the number line. So let's see what we end up with here. We do have another set of parentheses, so we will have to distribute here. So we get negative 3 times x, that's negative 3x. Negative 3 times 2 is a negative 6. And then we have the rest of our inequality here. Minus 2 greater than or equal to negative 23. Okay? Now we do have some like terms right there, the negative 6 and the negative 2, so we can go ahead and combine those together to give us negative 3x minus 8 is greater than or equal to negative 23. And then we go about getting the variable by itself. Get rid of the minus 8 first by adding 8 to both sides. 8's go away on the left, leaving us with negative 3x is greater than or equal to negative 23 plus 8 is negative 15. And then finally, to get rid of the times negative 3, we have to divide both of them by negative 3. Then write our answer over here. Negative 3's on the left cancel out, leaving us with just x. Negative 15 divided by negative 3, negative divided by negative is a positive, so 15 divided by 3 is 5. Now we did divide by negative right there, so the inequality will now flip around. It's no longer going to be open up towards the variable, but it's going to be open up towards the number. So we end up with x is greater than or equal to 5. So that would be our solve part of the answer. Now we need to graph it. And once again, when we have one inequality, the two numbers that we graph on the number line are the number itself and 0. All right? So at 5, since there's a bar, it's going to be closed. And once again, since the variable comes first here, we go by the direction of the inequality, and it is pointing to the left. And that would be our graph for that inequality. Now this one definitely was a little bit more of a complex one compared to this one, because over here we have a one-step inequality where we gotta get rid of the times 4 by dividing by 4 on both sides, which leaves us with an x. 16 divided by 4 is 4, and we divided by a positive, so nothing flips with the inequality, so it remains as x is greater than or equal to 4. Once again, for this one, we want to graph it on the number line, our two numbers being always 0, and then the number that they give us, which is 4 here. At 4, we have a bar, so it's going to be a closed circle, and since the variable comes first, the inequality is pointing in the direction that we want it to go, which would be to the right. Okay? That's the first page of this review. Let's go ahead and flip it over and do the second half here. All right? Now, once again, we'll notice the first two problems here say solve, no graph needed. The bottom 4 want us to graph. I will go ahead and let you know that I think the graphs at the bottom of our page ran off by the copy machine. So we'll fix those when we get to them here in a minute. But these ones don't need the graph. So we have a 3x is greater than 9 and negative 2x is greater than negative 20. All we need to do is get this to be x an equality number and x an equality number. Same thing over here for the or statement. Okay? So let's go ahead and do that. Let's do these individually. 3x is greater than 9. Get rid of a times 3 by dividing both sides by 3. 3's go away. It leaves us with x is greater than 3. And let's go ahead and do the other one over here. Negative 2x is greater than negative 20. Get rid of a times negative 2 by dividing by negative 2. Negative 2's go away. Leaves us with x. Negative 20 divided by 2. That's a negative divided by a negative, which is a positive. 20 divided by 2, which is a 10. Okay? Now the inequality, since we divided by a negative, will flip around. And that gives us x is less than 10. Now normally we don't see these two separated with compound inequalities. We normally like to see something like these ones down here, or this fashion right here as a final answer. So we could write that as our final answer, or since we're looking for the numbers that are greater than 3 but less than 10, we could write this, even though this is an excellent final answer, we could have just combined this to be one final answer, where x has to be between 3 and 10. And remember, if we always want to write it as a compound inequality in one statement, as long as your numbers are going from how they would appear on the number line, smallest to greatest, it'll always be less than symbols. The only thing you might have to look out for is if one of these needs a bar. In which case, in this one, neither one of them had a bar, so that also could have been a way we write our final answer for that one. Because remember, there's always two ways to write them for ands. For or statements, there's only one way. So we have 4x plus 5, supposed to be a 5 there, 4x plus 5 is greater than 21, or negative 3x is greater than 9. Once again, for or statements, we are doing these individually. So we're just going to focus on this one on the left. So we're going to get rid of that plus 5 first by subtracting 5 from both sides. Leave us with 4x is greater than 21 minus 5 is 16. And we get rid of a times 4 by dividing both sides by 4, which leaves us with x is greater than 16 divided by 4 is 4. Then we can bring down our or statement, and then we're going to go ahead and figure out what this one is over here. We have negative 3x is greater than 9. Get rid of a times negative 3 by dividing by negative 3. So the negative 3's on the left cancel out. Leaves us with just an x. 9 divided by negative 3 is going to be negative 3. And since we divided both sides by a negative over here, it's going to go from a greater than symbol to a less than symbol. Okay? So that would be our 2 for that one there. Okay. Let's take a look down here at this next one. Now this one's nice just because this is just a compound inequality. All the math's been done for us. We don't see the word or, so we know this is an and statement. We know that this should result in a segment on our number line. Now, as we remember, since they gave us two numbers here, those are going to be the two numbers we plot on the number line. We just want to make sure that we put them as they'd appear on the number line. Negative 2 and 4. Then we have to determine if we have open or closed. At negative 2, no bar means open. At 4, bar means closed. Once again, we do not see the word or here, which means we have an and statement. And that means we are just simply looking for the values between negative 2 and 4, so we just connect them together with that segment. Now, sometimes they won't be as easy as that. Sometimes they might require us to do a little bit of math like these next two do. Now, even though this isn't separated by the word or, since it's two separate statements, we do them individually. So we're going to just focus on this 3x is greater than 9. And we'll get rid of the times 3 by dividing by 3 on both sides. 3's on the left cancel out. Leaves us with x is greater than 9 divided by 3, which is 3. Okay, then we have the word and. Then we go about solving this one over here. Okay? Now. Yep, there we go. All right. Negative 2x is greater than negative 20. So, get rid of a times negative 2 by dividing by negative 2. So negative 2's on the left cancel out, leaving us with x is greater. Whoop, messed it up there. Got ahead of myself. Negative 2's cancel out to give me an x. Negative divided by negative is a positive. 20 divided by 2 is 10. And then since we divided both sides by a negative, our inequality is going to flip around. Now, some people might look at this and say, well, why does all that math sound familiar? That was actually the problem that we just did up here. Okay, it was the exact same problem that we did, where all we had to do was write them out. Okay? But this problem down here, okay, this just goes to show you that since it says solve and graph and the other one just said solve, all the math is done the same. Okay? So we need to plot these on our number line. Our two numbers are 3 and 10 as they appear on the number line. Both of them have no bars. They're both going to be open. And the word or does not appear here. So we go with connecting the two numbers together. Okay? Now we should be able to see that we've been connecting the numbers together because since the variables are both the same here and here, or sorry, they're both first, we go with the direction of the inequality. So at 3 we'll be going to the right, and at 10 we'll be going to the left. And basically that means they're just going at one another. Now up here, we had them written separately, but then we went ahead and combined them together, which shows us how we're looking for the x's between 3 and 10. Remember, all and statements, no matter if they're separated into two parts or one, should result in the segment. Okay? Okay, I'm going to fix this up down here at the bottom real quick. I should have two number lines down at the bottom of my page for these last two problems. You want to go ahead and pause the video and try these ones out on your own, you're good to go for it. Okay. This one here, we have 3x plus 4 is less than negative 14, or 2x is greater than 10. Once again, these are two separate parts here, so we'll do them individually. 3x plus 4 is less than negative 14. We get rid of the plus 4 by subtracting 4 from both sides. 4's cancel out on the left, leaving us with 3x is greater than negative 18. Then we're going to get rid of a times 3 by dividing both sides by 3, in which case we'll be left with x is less than negative 6. So that's our first inequality. Our other inequality, we have to do 2x is greater than 10. Get rid of a times 2 by dividing by 2, in which case, again, we have the word or in between them here. 2's on the left cancel out, leaving us with just an x. We divide by a positive, so the inequality does not flip. And 10 divided by 2 is 5. Now, since we have an or statement, we should have two rays going in opposite directions. Let's check that. I have negative 6 and 5 as my two numbers. Want to make sure I put them how they appear on the number line. All right, both of them are open because there's no bar at either one of them, so open and open. And once again, as always a reminder, when your variable comes first, the inequality is pointing in the direction it should go. So at the negative 6, it should be going to the left, and at the 5, it should be going to the right, which gives us our correct or compound inequality there. Okay? Last one, we have another compound inequality written as one statement. So since we do not see the word or in this, we know it's an and statement. So we know we're going to have to plot two numbers and basically connect them together, but it's not going to be negative 14 and negative 2. We have to get the x by itself first. Now keep in mind, when it's one solid statement like this, for an and statement written as one statement, no words in this, no ands or ors, whatever we do to get the x by itself here, we're going to have to do it to all three parts, not just the middle, but the left and the right. So we're going to get rid of that plus 4 by subtracting 4 from all three parts. 4's go away in the middle, leaves us with 3x. Inequalities stay the same. Negative 14 minus 4 is negative 18. Negative 2 minus 4 is negative 6. And to get rid of the times 3, we're going to divide all three of them by 3. So the 3's in the middle cancel out, leaves us with an x. Even though both of these are negative over here, we're not dividing by negative. We're dividing by a positive. So that means all the inequalities are going to stay as they were. It's going to stay as a less than or equal to symbol. It's going to stay as a less than symbol. Negative 18 divided by 3 is a negative 6. And then negative 6 divided by 3 is negative 2. Once again, we do not have the word or in here, so we know we're dealing with an and statement. All we need to do is plot our two numbers, how they'd appear on the number line now. Reminder, both of them are negative. It goes in descending order as it appears by the number. So negative 6 would come first, then negative 2. Now the negative 6 had a bar underneath it, so it's going to be closed. The 2 had no bar, so it's going to be open. And once again, since this is an and statement, we simply just connect them together because we were looking for the x values, between -6 and -2. Okay? All right. Once again, hopefully that helps you, or if that was just a nice review to hopefully get you ready for the Topic 1 test on Thursday. Reminder, this is not due Wednesday in class. It's due Thursday morning before your test. Just put it in the black bin with your name on it, and you'll get some bonus points for your test. Make sure to use this as a nice study guide for you Wednesday night so you're better prepared for the test. And once again, Wednesday I will not be in class. Thursday is still up in the air, but you'll still be able to take your guys' test on Pearson. Make sure if you have any questions over anything, I will be able to answer you guys through email, so just make sure you send me an email.